So in this video, we'll be going through a diamond data set, whereas you have different features, and we should be able to predict the price. So let me open the data set here. And these are the libraries that you need to import before we get started. Your tree. So let me quickly open the file. So it's copy the path and paste. So I think yes. So it's open. As we can see, this is not needed, this column, so let's remove that. So the column that is needed to be removed, and it has to be permanent, so in place equals true. What this does is, so it permanently deletes whatever the column we mentioned from the data frame. So as you can see, it's deleted. So we have different features such as caret, cut, color, clarity, depth, table, price, XYZ. Let's just check diamond data set. So, so this is a different clarity, one, 2, 3, 4, 5, 6, 7, 8 type of clarity. So I have to go through a bit more about this in order to understand. Okay, the image is not great. Yeah, so this is the color as well. DH and Z. Alright, let's go further. So the maximum is 5, whereas the 75th percentile is 1. There's a lot of difference. 62, 79. The minimum is 0.02 here. Okay. No, there's a huge difference here. Rising. TF.info. Let's see if there are null values. Okay, there are no null values. 53,943 data. And also you can see that cut, color, and clarity are categorical variable. So let's see the number of values. Yes. 'Ideal, premium, good, very good. So fair, good, very good. Ideal, then premium. Yep. Color. 2, 3, 4, 5, 6, 7. 7 different types of color. So let's check with clarity. 2, 3, 4, 5, 6. Let's check value counts. So ideal is the highest, followed by premium. Very good. Fair. Okay. So color. Let's check the color. So G is the highest. Other than that, G nearly colorless. You'll still see a fair light tint of yellow. So that's the highest. So DEF is like the purest, the colorless. DEF. Mhm. Let's check with clarity. SI1 VS2 clarity. SI1, okay, slightly there's some sort of dot or anyway. So let's explore the data a bit more further. Let's go with a pair plot. Yes, and that's dot. So yeah, so this is how the data is scattered. You can see some sort of outliers. Yeah, outliers here as well. Rise versus Z. Is a regression curve. Caret versus X. Let's see. Let's plot a correlation confusion matrix. We need to set up the size. So yeah, subplots, fixed size. 12, 12. That's usually the better size, as far as what I observed. Heat map. Not a confusion matrix for a heat map. So we have to alert. So one is the highest correlation, zero being the least, or no correlation. So we see a so strong correlation between X and Y. So X and Z, Y and S, Y and Z as well. So when the pricing has to do something with caret as well as X, Y, Z. As you can see here, pricing X, Y, Z. There's a correlation, a strong correlation. Even the carrot has a strong correlation with the pricing. So now let's use label encoder to change these categorical variables into numerical values. So the formula is um, IQRS Q3 minus Q1, and Q1 is the quantile of 5 0.2. Not DF, but whatever the column, whichever column we are trying to make it. So let's put this below here. And it follows by Q1 minus 1.5 times IQR. It comes between Q3 plus 1.5 IQR. So this basically there's a formula. So let's make this into a function. Yeah, remove outliers. So now we'll just give it as DF, which is of course the column. So IQR is Q3 minus Q1. So DF final. Mm, mm, mm. Yeah, DF of minus 1.5 IQR. That. So we need one more bracket here. Followed by. That should be greater. I mean, plus 2 IQR. So we need to have a DF that's anything lesser than lesser than Q1 minus 1.5 IQR, and between anything greater than Q3 plus 1.5 IQR. Whatever is less than that, whatever is greater than this, those have to be removed, right? So this is what happens. Let's see. So yeah, anything above this is like I will less than this is outlier. So you can see Q1 minus 1.5, Q3 plus 1.5 Q is more than that is an outlier. So we want only this. So right now we are considering whatever is outside of these as outliers. So those will be selected. So I hope it works. Yeah, let's see. Uh, let's see. Okay, df dot price. Let's assign it somewhere. Price removed. Okay, what exactly is the issue? See, I don't think we need this bracket. I'm not sure. Mm, well. Okay, let's see. So yeah, we got it right. So it'll be between enclosed brackets. So these are the outliers we've got. Let's see the length of them just to make sure. Okay, we have 3540 outliers. So I don't think we'll have to do with the pricing initially. So let's go with carrot. So let's name this carrot as well. So 1889 outliers. So all this we have to remove. So how do we remove? We need to. So we have the indexes over here in this. So we'll convert this into a data frame. The carrot remove. Let's see. Pair data of carrot remove. So we got this 1889 rows. We got the indexes as well. So let's write the loop, or let's write define if all clients. So I am if dot index df dot drop df dot drop. Okay, let's see. So dfc df column df. So the column and this is the data frame. So for the column we have index and the data frame we're using drop based on the index that we'll be providing. So index equals I, comma in place is true. We want permanently to be deleted, right? So what do we return here? Well, DFC, DFC, not DFC, DF. Yeah, there's a function. The column, so this is a column, DF. Let's see. Okay, so initially, how much was it supposed to? Okay, let's just delete this for now. Let's run through the whole thing again. I'll show you that it is been deleted. The data frame, the number of values in data frame would have been reduced. So this is shit. Something seems fishy. Let's do it again. Okay, so we haven't removed, sorry. So remove outliers. What is the column? df dot caret comma, or we can just no, this is a column, right? And the data frame. Yeah. So now, okay, only one is removed. DFC dot index. Or no, it shouldn't be here. It's in the function as well. Yeah. Okay, let's run through it again because already the one of the index would have been deleted and that would have been an issue. Yeah, so we can see that close to 1,800 are gone, which is the same number here, 1,889. So we remote carrot. Let's do the same for. I think we can define. Okay, never mind. Let's try to define a function for this as well. Df final comes out. Df. Let's do it here itself. So let's try this out. So what we're doing is we are converting it as a data frame before we even get it. But assigning this is the issue, right? Let's try. Let's name this character GF. DF dot. Let's try with the one depth. Yeah. Oh no. Depth. 2796. Okay. Seems realistic. So yeah, we can do it here. So we can probably ignore the steps and we can actually put this in. And then we can pass it on. Sorry, let's just copy this separately below. These are the three steps we need to follow. Oh, sorry. And then there's also defined, so we can take this. These are two things we need to modify. So depth, yeah. So let's give it a try. I think the length of depth was, let's work that out. So 2796. So it was 2796. I think this does it make sense? 796. So yeah, makes sense. So depth is also taken care of. So let's deal with table. Table, change it as table. Okay, there's some issue. Okay, table. Okay, let's see the length of this. It's sensible. 342. Makes sense. So let's also see length of DF. So remote 342. I think last time we had around 4925. Yeah, 342 or remote. So let's delete based on the next value with next feature, which is okay, price. Let's not touch the price, let's touch X, Y, Z. Let's look at the price and the law after we have cleaned this. So in price, what am I doing? I told we go with the price later, right? So let's do the price later. The reason is let's check if there's still outlier and then let's decide if we want to go ahead or not. Okay, six already used, right? Six outliers. Yeah. Let's do the same for Y. Okay, I think only one outlier was there. Land of yeah. Let's do the same for Z. I think by now the outliers would have minimized hugely. Well, eight outliers. Yeah. So let's check with the pair plot now. TF and let's see. Okay, there are still some outliers. Sure. But we can see strong relations, right? Strong graphs, strong regression. Did we do for table? I don't think so, right? We didn't do it for table. Oh, we did for table. We still have slight outliers. Yeah, outliers removed in depth by X, by redepth by Y. Caret. Well, let's give a shot with the pricing and see if it makes a difference. But yes, we see a strong regressions right now. We can already see very strong regressions X, Y, Z. Especially with the pricing. Not so great, but yes, compared before. Well, a lot of outliers are removed. Let's see. Can we look at the distribution now? Yeah, with respect to pricing, a lot of outliers are removed. We still have few. I think X, Y, and XZ have a strong correlation. These have strong correlations. Well, there is still a distribution of data. I don't think a regression is the right model for this, but let's see. Okay, let's convert this categorical data such as cut, color, clarity into numerical values. So let's use label encoder. sklearn dot pre-processing, right? Label. Let's see label encoder. Label encoder equals label encoder. So let's do this. So let's convert cut first. So df of cut dot fit transform of df dot cut. So let's see. Yeah, it's already good. Let's do the same thing for the others as well. So color, clarity, change it here as well. Color. clarity. Yeah, should do the magic. Sorry. So yeah, it's converted. So now we have to perform a cross validation to see which model suits the best. So let's get into that. sklearn dot pre-processing only. Okay, it should be model selection. Cross validation. Let's go. Yeah. So actually, before we do this, we have to split the data. So let's split it. String. Okay, let's go here. Access df dot list of the target value, which is target feature, which is the price. Access one. No, yeah. So df dot price. Pretty much it. 6 comma y comma test size. Uh, train test split test size. Let's go with zero point 0.3. So let's see x train and let's see x test train. Okay, my bad. X train x test. So let's see this. So x train test. Well, actually, you don't need to fit that. So there is enough. Don't need that. From sklearn dot crossing dot cross model selection import cross. It's also we need to import the model. So let's go with linear model first. Version CLF classification is this, right? And on your scores is cross validate score of what? X comma y comma CLF See, let's keep it 5. Let's see. I think we'll have to put this here. First, the classification, then let's call it. Okay, so start with uh I guess it's not bad. Let's NP dot average of scores minus 1.93. That's close to zero, but let's see. So let's go with decision tree. And, okay, sorry, not ensemble, it's tree. Decision tree classifier regressor. Let's go with classifier. Oh, something is very fishy. Let's try the classic, the regressor. Oh, I see. We didn't change it here. That's the problem. Let's keep this close. J minus 0.029. Oh, that's even better. Well, let's try random forest. Random forest classifier. So I think the issue could be Random probably mentioned the estimators. Let's go with 20. I don't think we need this. Let's see. So we got the value, it's 0.006, but this is the accuracy, which means 6%. That's really less. Let's move on with the next one. Let's see. Dot. I think decision tree is done, right? Yeah. I don't think so. This is a good idea. Okay, let's go with. Let's import XGB boost. regressor. Okay, so let's try with XGBRF. Now it's a manual view, so let's try regressor again. It should work. Classification metrics down, multi-class and continuous targets. Let's try for 100. It's supposed to work. I'm not sure why it's not doing accuracy in that case. Let's just give it a try. Okay, so we got it. We got score minus 0.13. So minus 0.13. 0. Well, this decision tree seems to have the least. So can we try that? Yeah. So let's split and train. 0.13 minus 0.29. Okay. Let's try with scoring as accuracy and see. I don't think it would work. Yeah, I think there's an issue. Let's remove that. Let's remove this. Okay. And how do we stop this? Okay, let's see what this 1 3. Okay, decision tree seems by far the best fitting as per the scores. Let's see. Let's do the train test split. sklearn dot model selection Unicode dash x train comma 1 with x comma y comma test size 0.3. Let's go with decision tree. CLF dot x x train y train. Okay, I think we messed up here. Near the train test with x train. Let's see the syntax. X train x test trains keeps. Sometimes you get confused, right? Let's see. Example. X train X test, Y train Y test. X train X test. Yes, I think it must have been. Y train. A lot of people get confused with this sometimes. Let's see, zero dot score X test Y test. Okay, 96% accuracy. Also wanted to try with this, even this was by far the most least, right? Yeah, compared to linear regression. Wow. So yeah, let's try this. 95% accuracy. So that or this both works, I believe. I mean, but by far this has been the most accurate seal of dot. Let's try it behave written based on this. 99% accuracy. It seems like decision tree is by far the best. And also I think yeah, SGB boost is also pretty accurate. Yeah, with 96% accuracy. Let's try something. First we'll have to remove this. The pricing. What was the pricing? 326. So we'll have to remove the pricing. Oh, it has to be in an umpire array. Yeah, 326. Yeah, that is accurate. Let's see this randomly. We can also save it as a JSON file and then Sorry, 6. Yes. Well, so yeah, that's it for now. So you'll have to delete this. This is what we did. So quickly, we read the data. We imported the data. We dropped unnecessary column, which was this. Then we just went to the statistics. We saw the max, so the minimum, 25th percentile, 75th percentile. Info to check null values. So see a different unique distinct values. Then which has the highest, which unique values have more value counts. See the correlation, see how the data is scattered and check for any outliers. Then see the correlation here using heat map and correlation matrix. Then remove the outliers using IQR method. Then after once the data outliers were removed, we again saw how the data was in we saw no outliers. As you can see, hardly any outliers. Yeah, we could find a strong relation of so we can see uh, a strong correlation as y increases, x also increases. So y less outliers, and you can see strong shape. Moving on, we did label encoding, convert categorical variable into numerical values for to fit to fit in for the model to predict. Then we made x and y. This is a dependent variable and others being independent variable. Also, price being the target variable. So we used cross validation to see which model was fitting, which would be the best fitting model. So after figuring it out, it's decision tree. Well, we split the data, train test split, and then we uh, train the model using save.fit. Then we check for the score, and then we predict. So that's it for this video. So hope this one's helpful. And yeah, thank you.